Hi students, so now we will be solving this particular problem, okay, which is nothing but integration of sine 2x divided by a square cos square x plus b square sine square x dx. Now this problem I chose because I gave this problem because there are two cases that we will be dealing with. First we will solve this problem in a regular way and then I'll tell you what the irregularity is, okay. First is when you see this question, how will you solve it? Let me tell you. Now this is a bit of a trick, you can say, or you can also say with lots of practice and experience you will gain this, okay. In this question, what you have to do is you have to take b square minus a square in the denominator as well as in the numerator. I hope you are understanding what I am writing here right now, okay. So why did I do this? Why did I divide it by b square minus a square and multiply it by b square minus a square? You'll get it soon. But I hope you understood why I wrote 2 sine x cos x here, because that is the formula for sine 2x. Have been told to you multiple times. I hope there is no other doubt as of now. Now we will see that why did we use multiply b square minus a square both in the numerator and denominator. Now if you take f of x as your denominator, in case say f of x is your denominator here, so we get something like this, right? Now tell me, what will be the differentiation of this particular function? What will be the f dash x of this particular function which has been given to us? This will be nothing but a square 2 cos x sin x, and this will be nothing but b square 2 sin x cos x. These kinds of differentiation I have done before, so I hope this will not stand as a problem for you. In case you forgot, let me remind you that cos square x is nothing but cos x whole square, whatever you call it, okay. So this is cos square x. Now cos square x can be written as 2 cos x, okay. First we have to differentiate the power and then we have to differentiate the trigonometric function, which is nothing but minus sine x. Similar is the case for sine square x as well, okay. So that is why we have done this particular thing here. Now let us try to simplify it a bit. If I take 2 sine x cos x common from here, then I'll get a minus a square plus b square, and then what will I do is 2 sine x cos x, all right. Two sine x cos x b square minus a square, all right. So in order to get this format, we multiplied and divided by b square minus a square here. I hope you get it why. I did that so that I can get the f dash x by fx format. For doing that only I did this, okay. Now in the examination hall, you might not arrive to this particular thing as soon as you see these kinds of problems. For that you have to first take this as fx and then test whether what are the things that needs to get multiplied and divided. From there you will understand, okay. Directly you might not understand that what will I divide it or multiply it with, but once if you get your fx, okay, you roughly assume that this as your fx, and then you see that after doing f dash x you will have certain extra component. Now that extra component will be put in by form of some manipulation, multiplication and division. That is what only I have done here, okay. Now you know what to do. because we have this format directly. So now we will just come like from here to here. What we will get? Log of 1 minus b square, 1 by b square minus a square will remain as it is, and we will get log of what? A square cos square x plus b square sin square x plus c, right? So this will be the answer for this particular question. Now, as I told you, we will be considering two particular situations here. We will be considering a situation of a equal to b and a situation of a not equal to b. Now, for this particular solution, this case 1 was for when a is not equal to b. Now, in case when a becomes equal to b, then the interesting thing is that this function will no longer get applied, the theorem that I told you. How? Our case 2 will be a equal to b. Now, once we do a equal to b, what do we get? We get sine 2x in the numerator, and in the denominator we had a square cos square x plus b square sin square x. But since a is equal to b, our a square here will be equal to like the b square here, right? So in the place of b, we can replace by a, and we will get something like a square cos square x plus a square sin square x, right? Now if we get that, after this what we will get? We will take a square common. When we take a square common, then we are left with this particular thing, right? And when we are left with this particular thing, we can write this entire thing as 1. Cos square x plus sin square x is 1. Now I take a square outside and I simply get, I'm sorry, I forgot to put dx here. Please don't make these mistakes. Okay, so it will be 1 by a square. What is the integration of sine 2x? Nothing but minus cos 2x by 2, right? Plus c. To make it look a bit better, I can write this as 1 by 2 a square minus 1 by 2 a square cos 2x plus c. So this is the answer for this particular question, and you saw that in our second case, we did not even require to put the theorem that we had before, right? The theorem that we had before, we did not need to put here. What theorem? That log theorem that we did have, integration of f dash x by fx. There is no such format which is coming here, okay? This is why we don't need to apply this particular form here, okay? We do not need this format. We are directly coming to this easy integration. Why will we again make so many variations? We don't need also. We don't need to make such variations because this is a direct integration, okay? So now we will move to the next problem. So now we will be solving this particular problem, okay? This problem is actually a bit easier than the previous problem that I actually solved, okay? So how will we proceed here? Simple. First, we have to divide the numerator and denominator by e to the power cx. Now I will approach in a more uniform way so that you can understand what I am doing. Now first you can understand that here if we take f of x as this particular function, okay, then what we will get in the place of f dash x? In the place of f dash x, this particular thing will become 0, and here what we will get? Okay, no, first let me do one particular thing here because this will create a problem otherwise. What we have to do here is first we will divide the numerator and denominator, okay, by e to the power cx, okay? So if I divide the numerator by e to the power cx, I will get e to the power minus cx in the numerator, and in the denominator if I divide by e to the power cx, then we will get something like this, okay? Now by doing that, you can roughly understand that we have our fx in the denominator and f dash x in the numerator. In order to prove this further, you can do it in your rough that if fx is this thing then f dash x will be nothing but, tell me what is the differentiation of this particular function. If I differentiate this function, what will I get? A will be a constant here, e to the power cx, c will come here, okay? And all right, I did not a mistake but a blunder here. It's not e to the power just cx, it's e to the power minus cx, okay? Because I have divided numerator and denominator by e to the power cx. I haven't multiplied it, okay? I have divided the numerator as well as the denominator by e to the power cx. So definitely when it comes on the upper side, it will become e to the power minus cx, right? So if I do that, this will become e to the power minus cx. And so here what we will be having? We will be having a here as it is, and then we will be having e to the power minus cx, okay? And we will be having a constant here as well, and this will be 0. So this will become minus ac e to the power minus cx. I hope you understood the integration for this, for the differentiation of this. Actually, this is something that you deal with directly in differentiation. E to the power any function is actually differentiation of e to the power of any function is actually e to the power, okay, say e to the power x. The differentiation of e to the power x is e to the power x. Now if a constant is placed in front of in the front of, say, we have e to the power ax, say, okay? So when we differentiate this, it becomes a e to the power ax. Now if there is a minus sign here, then this will become minus a e to the power ax. This is something which is done in differentiation chapter. So in case you haven't done it properly, then you have to wait a bit. Till then I am trying to introduce you to it as much as possible, okay? Just remember this thing in case you don't know, and apply it directly here. This is a direct application actually. In integration, no such difficult levels of application of differentiation comes in the initial stages. Maybe in the later stage, if you try to solve JEE mains and JEE advanced problems there, maybe you might have to face such difficult differentiation. So you must be knowing all of the things properly, which I'll be doing in, like, it will take a bit of time, but I'll be uploading videos on that as well, okay? So this is the final thing that we arrived in. Now we can see that in the numerator, in the denominator we have f of x, but in the numerator f dash x lacks two things. What? First is the minus sign thing, and the second is the AC thing, okay? Two things that we need to account for. So what we will do, simply multiply and divide, right? Now you see, you directly get an f dash x by fx format. Just divide and multiply by the extra part that we have, and that's the end of the problem. Now you know what to do. You need to put it like this, and in the log mod section put this thing, then plus c. That gives you the final answer to this question, right? Log of what? A plus b e to the power cx, right? So minus of 1 by ac log of mod a plus b e to the power cx plus c. So this is the final answer to this question. Now we will solve one more problem based on this formula. So this is the problem that we will be having here, okay? Now how will we solve this particular problem? In order to solve this problem, we have to first break the thing, okay? How do we break? We know tan x is nothing but sin x divided by cos x. So this will be 1 plus sin x by cos x, okay? And then here we will be having dx. Now what is the next thing that we will be doing? Simply do the numerator denominator thing. We will get cos x minus sin x by cos x. Here we will get sin x plus cos x plus sin x, or sin x plus cos x, whatever, like this, integration dx. So cos x get cancelled, and then finally Finally, where do we arrive? We arrive at cos x minus sin x divided by sin x plus cos x, right, dx. Okay, so now you can very easily see that here we do not have to do any form of manipulation, because this is our fx, this is our fx, sin x plus cos x. And what is the exact f dash x of this fx? Sin x is nothing but cos x, and cos x is nothing but minus sin x, right? Sin x is cos x, the differentiation, and differentiation of cos x is minus sin x. So we directly have the f dash x by fx format here. So we will be putting nothing but log of sin x plus cos x plus c. I hope that you understood this problem. Okay, I hope there isn't any doubt further, because everything has been explained here. All right, okay, so now that we have completed our part for we have solved a lot of problems based on this theorem. Now we will move on to the next format. Okay, and meanwhile I'm trying to solve a bit more problems which will come as a practice problem, which you will be solving it, and in case you will have a doubt, I'll explain it to you. All right, so till then, all the best. Now let's move on to the next video.